This is my prototype for round 2 AstroGuard, an AI-powered orbital collision prediction visualization system. It integrates with the orbital mechanics simulation, 3D visualization, and machine learning in a single operation interface. So what's the problem? Why are we doing this? That's the main reason. So as a satellite launches increases and debris accumulates in low Earth orbit, predicting conjunction event has become extremely complex, time critical. AstroGuard solves this by automating orbit propagation, close approach detection, and risk classification. So here in the simulation setting, these are the simulation settings: duration, total runtime of the simulation, time step, sampling rate, lower time step increases orbital accuracy, debris count, number of synthetic debris objects generated, TLS to load. This in this we load the actual satellite imported, real satellites import from the Celeste track, and threshold distance. This is a minimum separation for an event to be flagged as a potential conjunction. So AstroGuard propagates all satellites and debris orbits using SGP4 model or synthetic fallback. The SGP4 model and the synthetic fallbacks are the model we import, and at each time step, it computes the Euclidean distance, relative velocity, and time to uh, closest approach between every object pair. The simulation summary. Let's discuss about the simulation summary. The summary shows the total number of the objects simulated, the number of time steps analyzed, and the number of close approach events detected on the based on the threshold. So in this A and B, the A and B are the objects IDs involved, the satellite or the debris. Distance kilometer is a separation at the encounter. Rail speed kilometers is the relative velocity between the two objects. TCA is the predictive time to closest approach. DV is the approximate delta V required for a small avoidance maneuver. These parameters forms the core feature set for the machine learning models. So there is a 3D preview, the preview frame index. The slider allows us to scrub through the simulation timeline and visualize object position at any frame. On the left, the 3D interactive orbit viewer shows Earth, satellite orbits, and debris trajectories. This helps visualize the conform conjunction geometry and understand orbital motion. So there's a training panel which shows us the accuracy score, recall charts, and F1 and precision. AstroCard extracts distance, relative velocity, and TC as a features from each event. These are used to train 7 ML model, logistic regression, random forest, gradient boosting, botting, XGBoost, NeuralNet, KNN, and SBM. The system evaluates each model using accuracy, F1 score, precision, recall, providing a complete performance profile for collision risk classification. So there's a visualization panel, charts and model for the charts and models. There's a visualization panel. The visualization panel allows users to export the standalone 3D orbit files and performance plot, which can be reviewed independently or shared with the mission teams. We can just download it from the save orbit. It is saved, then we can download from the download orbit HTML, and then it is downloaded, and we can just open it, and we can do the prediction. They can do analysis, and they can do the prediction if it's gonna collide, there's gonna be a collision or not. So these are modern performance. There's an accuracy score and the F1 score. We can see the chat, the logistic dation and random forest are doing the best. There's a SBM, KNN, and NeuralNet, which are also doing the great. The logistic regression has given there's a 93.33% for the SBM, 94.46% for the KNN, and then 98% for neural net, and they more good accuracy scores among all the 7. So we can also export the system. We can go to the download panels, and we can like all train models, scalars, charts, and the orbit visualization are packaged into a structured GIF file for easy submission or the further processing for the further data analyst. uh, this prototype demonstrates a complete technically feasible approach to an automated orbital safety using simulation and AI. So thank you. That's it for the presentation.